Unit 1, Lesson 1.3, Packing It In, pages 13 through 15 in your textbook. In this section of the textbook, we're going to talk about density. We're going to discuss how mass, volume, and density are related. So if I change the mass, how does that affect the density? We're going to calculate density using the density formula or the density triangle. So on page 13 of your textbook, make sure that you highlight the definition of density. Again, this is a very important vocabulary word. Remember that the density of water is 1.0 grams per milliliter. You could also put grams per cubic centimeter. If something floats in water, it has a density less than 1 gram per cubic centimeter. If something sinks in water, that means it has a density more than 1 gram per cubic centimeter. In this example in your textbook, it has a scale, and on one side it has a whole bunch of feathers, and on the other side it has a tomato. This scale measures weight, and so each object has the same weight and has the same mass. But there is more volume taken up by the feathers than there are in the tomato, and this is because of the property of density. The feathers are less dense than the tomato. So as you read through this section of the textbook, you have an active reading question. So take a moment to pause the video and write what is density in your own words. Then you have an activity to predict. And it asks you to predict in each pair of objects which one is more dense. So pause the video and write your answers in. So for the first set, they are both about the same size, but a golf ball is going to be more dense. The middle, of course, the milk carton that's full is going to have more mass in it. They're going to have the same volume, so the milk carton that's full will be the most dense. And then you have a foam ball versus a baseball. And the baseball, if you know anything about it, has a cork core with some thread, and so it's going to have more mass, have about the same volume, so the baseball will be more dense. So I want you to write that information about the density of water on this space that you have that's empty on this page 13. So pause the video, write in this information, and then come back to the video when you're finished. It's not showing the GIF. There are two types of igneous rocks. You have pumice and basalt. So in the GIF on the left, the person drops that rock into the water and it floats, because pumice has a bunch of empty air bubbles inside of it because it was thrust into the air and solidified rather quickly. So it has a density less than 1 gram per cubic centimeter. Basalt is another igneous rock, doesn't have any air bubbles, and it has more mass per volume. Its density is greater than 1 gram per cubic centimeter. The volume for density is mass divided by volume. And this cute little example that if you cut the top part of the heart off, you end up with m divided by v. You'll become familiar with these triangles. They're going to help you figure out what to do with equations. So it's kind of a help. You can also derive the equations to solve for what you want to also. So it depends which one you want to use. If you want a little bit of a challenge, you will derive the equations. So put this information on that notes page, page 18. Pause the video, fill in this information, and then come back to the video. Okay, on page 14, they want you to read that first section up there at the top and then do some sample problems. You see the picture of pumice and obsidian at the top, with pumice floating and obsidian sinking. And so you're going to do some work on determining the density of those two igneous rocks. And so they do a sample problem for you, which is the one with the pumice. And the one that they work through for you is pumice is an igneous volcanic rock formed by the rapid cooling of lava. What is the density of a 49.8 gram piece of pumice that has a volume of 83 grams? So take a moment, work through the example, and then come back to the video. Write what you know, what you want to know, the formula. Substitute what you know into the formula, and then solve. So with this, you find out that the density of pumice is indeed less than 1. Oh, sorry, I guess they gave you the example of obsidian in your book. Sorry. So the problem that they want you to work on your own is obsidian is another type of igneous rock that has a mass of 239.2 grams and a volume of 92 centimeters. So work through the problem, pause the video, and then come back when you're finished. So you write what you know. You write what you want to solve for, which is density. I didn't write that, sorry. Write the formula, substitute what you know in the formula, and then solve. And indeed, igneous has a density greater than 1. Here's basalt. So if you go on to page 15, it gives you a sample problem. Work through the sample problem, pause the video, and then come back to the video when you're ready. So for this problem, you are calculating the mass. And so this is where that density triangle is going to come into handy. So I just pulled up somebody else's PowerPoint so we could look at their triangle. And so if we want to determine the mass, that's up here, then what we're going to do is we're going to take density times volume. If I wanted to find the volume, then I would take mass divided by density. So the line across here is divide, and the line down here is multiply. So when you're using the triangle, keep that in mind, that mass divided by density equals volume. Mass divided by volume equals density. If you want to find the mass, you have to take density times volume. You're going to see these triangles throughout the years we use them, but you can also derive the formula. So when you derive the formula, you use algebra. And so here I have density equals mass divided by volume. I want to solve for m. So I take each side by the reciprocal of v. and that's going to move V over to the other side. It crosses out here, and it gets pulled over here. So then I get volume times density equals mass. You substitute in your knowns. Your units cancel out because they're on the top and the bottom of the equation. And you get 16 times 3, which is 48. The unit that's left is grams. And I shouldn't have cubic centimeters there, so you can take that off. Okay, so they did one problem for you, and now they want you to do another problem. This time they want you to do it with a rock called rhyolite. A rhyolite rock has a volume of 9.5 milliliters. The density of the rock is 2.6 grams per cubic centimeters. What is the mass of the rock? Pause the video, work through the problem, and then come back to the video when you're ready. So here's the answer as if you were going to derive the formula. If you use the triangle, you would simply, you want to know the mass, so it would be density times volume. So you take the density times the volume to find the answer.